lesson 34, are all parabolas congruent? So it says, are all parabolas congruent? Use the following questions to support your answer. So it says, draw the parabola for each focus and directrix given below. Alright, so it's kind of hard to see your directrix, so I highlighted the directrix on mine, so that way you can kind of see what it is. So the directrix here is y is equal to -1, and the directrix on this one is y is equal to -2. If you remember in the last lesson, we learned that the point on the parabola to the focus point is the distance between those points is equal to the distance between the parabola and the directrix, that point and the directrix. So let's think about this. Where does my parabola have to sit? Well, let's just go from the focus point to the directrix. That is 2. The distance is 2 from the focus point to the directrix, which means if the point from the parabola to the focus point has to be equal from the point to from the parabola to the directrix, I need to divide that in half. So I know that I'm going to have a point here for my parabola. Alright, which means that I can go next and say, okay, well, if I want to put a point 2 away from the focus point, that means it has to be 2 away from the directrix. Alright? And I can go over here and do the same thing. Alright? What if I want to make a point that is, I'm sorry, that's not 2, is it? Yeah, that'll work. That's okay. Alright? Let's go up here and let's say, okay, I want it to be 4 away from the directrix. Well, there's 1, 2, 3, 4. It's not 4 away from the directrix, is it? Alright, so I have to be really careful. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what if I put my point here? Alright? Alright, so then I can create my parabola here. Alright, so now let's look at the next one. Now my directrix is -2. Well, the focus point is at 2. That means there's 4. Alright, divide that in half, and that is going to be 2. Alright, so 2 and 2. The distances are equal. Alright, so I'm just going to go, okay, let's go to 4, and I'm 4 away. So here's this parabola. Alright, so what do we mean by congruent parabolas? Well, 2 parabolas would be congruent if we could find a sequence of rigid motions that takes one parabola onto the other. Alright, and when we're talking about rigid motions, we are talking about reflection, translation, rotation, that kind of thing. So are the 2 parabolas from part A congruent, and explain how you know? Well, let's think about this. They have the same vertex. But is there a way for me to either translate, rotate, or reflect to get this parabola onto this parabola? They have the same vertex, but they have different y values. All right, for each x. So x is 0, y is 0. X is 2 here, but x is 4 here. All right, so an x would be 5 here, and I'm pretty sure I made the wrong thing there. All right, so they have different x values, or different y values for each x in the domain, except for the point 0, 0. If we translate the first one somewhere else, then the vertices would not line up. Translate means to slide. So if I slide the first one up or down, then they don't match up. If we reflect or rotate, then I change the direction that my parabola is facing. So therefore, they're still not going to be able to do it. So they are not congruent. Because we cannot translate, rotate, or reflect to get the one on top of the other. Alright? Alright. Are all parabolas congruent? Well, we just answered that question. No. We just answered that. These are two parabolas, but they're not congruent. Under what conditions might two parabolas be congruent? Well, so what we need to know is we need to align the vertices. Alright? 0, 0 is the vertex of this one. 0, 0 is the vertex of this one. If you remember, in lesson 33, I gave you the definition of the vertex, and that is the point where the axis of symmetry intersects the parabola. In other words, where I can fold this parabola in half, then I have this being my axis of symmetry. Alright, so we need to align the vertices. Alright, so find that vertex and align it. Alright, our directrix for one parabola and the directrix for another parabola need to be parallel. In this case, our directrix are parallel. Our vertices line up. Alright. The parabolas need to open in the same direction. Alright. And I can use rotation or reflection to get that to happen. And they will have the same shape if the focus and the directrix are aligned. Alright? So, here's what we get out of this whole thing. Two parabolas will be congruent if they have the same distance between the focus and the directrix. That right there is the one thing that you need to remember in this whole lesson. If I have the same distance between my focus and the directrix, then the two parabolas can be congruent. Going back and looking at this, the distance between my focus and my directrix here was 2. The distance between the focus and the directrix here was 4. They are not the same. So therefore, they are not congruent parabolas. All right. So, how can we use the definition of a parabola to quickly locate at least 3 points on a graph of a parabola with the focus 0, 1 and the directrix -1? All right. So, let me kind of draw this out really quickly. All right. So if I have a focus at 0, 1, there's my focus, and my directrix is at y is equal to -1. So here's my directrix. How can I use the definition of a parabola to quickly locate at least 3 points on the graph? So the distance between the focus and the directrix is 2. All right? So 1 point, the vertex, will be halfway between them at 0, 0. All right? Since the distance between the focus and the directrix is P is equal to 2 units, if we go 2 units to the left and 2 units to the right of the focus, we will be able to locate 2 more points on the parabola. So if I go 2 units to the right and 2 units to the left, then I can create the next 2 points of my parabola. All right? So I end up with a point of 2, 1. And I end up with a point of -2, 1 here. All right? So how can we use the definition of a parabola? Well, then you can draw your parabola. Okay? So how can I do it if the directrix is, let's say, my focus, and I'm just kind of running through some examples really quickly for you. Let's say that my focus is at 0, 2, all right, and my directrix is at y -2, all right. So here's my directrix, and here's my focus. So now I'm going to count the distance. So 1, 2, 3, 4. So my distance is 4. So now I can go 1, 2, 3, 4. All right. So I'm going to go 4 points from my focus, and I'm going to go 4 points from my focus. I already know that one's going to be 0, 0, because that's halfway between my focus point and my directrix. And so now I have my parabola. Okay? All right, so generalize this process. All right, so here's what I'm going to do. I'm going to find the vertex halfway between the focus and the directrix. And then I'm going to find the distance between the focus and the directrix. And then I'm going to sketch a line through the focus parallel to the directrix and locate the 2 points that are along that line. All right, which I didn't do. I didn't draw that line through the focus. But basically, I'm just going to find 2 points on that line that goes through the focus. Okay? All right. How does this process help determine if the 2 parabolas are congruent? Well, remember, 2 parabolas are going to be congruent if 2 points found through this process are the same distance away from the focus. All right? 2 parabolas are going to be congruent if they have the same value or the same distance between the focus and the directrix. All right? All right. the given focus and directrix. All right, so we've got to think about what this is going to look like. Guys, I would turn this so that you can see an XY axis. Okay? We're just going to do a very rough sketch here. You know, not going to be anything of perfection. But let's think about this. I want to have this going through here. All right, so I'm going to kind of estimate. I'm going to draw that line through my focus point that's parallel to my directrix. And I want my point to be the same distance as it is from my directrix. So we're going to estimate about right here and about right here. And here's my, oh, no, sorry, halfway between. So here would be my parabola. All right? That would be my parabola. All right, let's go to here. So I'm going to turn my paper again. There's nothing wrong with turning that paper. I'm going to draw that line that goes through my focus point. I'm going to find the vertex, which is, and I'm just going to draw like that's my y-axis. So my vertex is going to be halfway between the focus point and the directrix. All right? And once again, I want my points to be the same distance as they are from the directrix. So I'm going to look about like this. All right? And I may have made that one a little bit big, but that's okay. We get the point. All right? And then let's do this. All right? And I'm just going to flip my paper completely over. Here's that focus point. All right? Here's the y-axis. My vertex is halfway between. All right? I want my point to be the same distance. All right? So if my distance is here, then I want it to be about here and here. And there's my parabola. All right, so I have these three parabolas drawn. All right. What two geometric objects determine the set of points that form the parabola? Well, a point called the focus, and then a line called the directrix. All right, that's how I figure out my parabola. What can you conclude about the relationship between the parabolas in exercise 1, 2, and 3? Well, if you look at them, they all appear to be about the same size and shape because the distance between the focus and the directrix stayed the same. So what do I know about these three parabolas? They should be congruent. So they appear to be the same size and shape. All right, because the distance between the focus and the directrix stayed the same. So they should be congruent. Okay? They should be congruent because the focus, the distance between my focus and my directrix stayed the same. Alright, let P be the number of units between the focus and the directrix as shown. As the value of P increases, what happens to the shape of the resulting parabola? Alright, so let's think about this. Here, I've got a distance of 1. What happens if I change the distance of 2? And we can kind of look here, going back to these two parabolas. Here I had a distance of 2, and here I had a distance of 4. So as the value of p increases, the graph either dilates or shrinks vertically. Because look at this. Here my directrix increases, my parabola dilates. It becomes wider. If I were to shrink my directrix, or the difference between my focus and the directrix, my parabola would start to become more narrow. So as p increases, the graph is dilated and it shrinks vertically compared to the graph with a smaller value of p. In other words, it appears to get flatter. Because like I said, if you go back to this, look, it appears to open up to eventually become flatter. Alright? Alright, example number 1. Consider a parabola P with a distance of P is greater than 0. Between the focus with coordinates 0, 1/2 P, and the directrix y is equal to negative 1/2 P. What is the equation that represents this parabola? Okay, so it tells us that P, the distance, is greater than 0. The focus has a coordinates of 0, 1/2 P, and the directrix is at negative 1/2 P. So what are the coordinates of the vertex of our parabola? So our vertex has the coordinates of 0, 0. Alright?
I found this on the web.
Sorry. Alright, so we're going to take the distance formula, and we're going to find the distance between the focus and our point x, y. Alright, so I need to find the focus between, or the distance between the focus and my point x, y. Alright, so distance is equal to x minus 0 squared plus y minus 1/2 P squared. Alright? So that's my formula. We're going to hold off for that for just a second. Now we need to find the formula for the distance between my point and my directrix. Well, remember, they share the same x coordinate. So to find the distance between the y coordinates, I would subtract. So y minus y plus 1/2. Alright? So, and they've actually already done that for us. So from the point to the directrix, I get y plus 1/2 P. Alright? Find a formula, by the definition of the parabola, we're going to do what with these? Well, remember we found that with a parabola, the distance between the focus and our point is equal to the distance from our point to our directrix. So now we're going to set those equal. So y plus 1/2 P is equal to the square root of x minus 0 squared plus y minus 1/2 p squared. Alright? Start by squaring both sides. So I get y plus 1/2 p quantity squared is equal to x minus 0 squared plus y minus 1/2 p squared. Alright? Alright, so let's go ahead and I want to show you something. I'm going to save you just a little bit of time here. Well, I don't know that it'll save you any time, but go ahead and square this. So I get y squared, 1/2 p times y is 1/2 py, and 1/2 py, so that would be 1 py, and then I get 1/4 p squared. Alright? Is equal to x squared plus, I get y squared minus, I get 1/2 py and 1/2 py, which is a negative py, plus 1/4 p squared. Look what happens here. I'm going to subtract the y squareds. They cancel. Look at what happens here. If I subtract 1/4 p squared from 1/4 p squared, they cancel. Alright? So I'm left with py is equal to x squared minus py. So add py. I have 2py is equal to x squared. I need to solve for y. So I'm going to divide by 2p. So y is equal to, and you can rewrite it as 1 over 2p x squared, or you can leave it as x squared over 2p, however you want to leave it. Alright, so therefore, this is my equation for my parabola. Alright? Alright. Guys, we have a lot of discussion in this next thing. Here's what I need you to do, is I need you to read through this. I am not going to read this to you on video. But it is super, super important that you read through this. Alright? Alright, example number 2. Given a parabola P, given by the directrix L and focus F in the Cartesian plane, then P is congruent to the graph of y is equal to 1 over 2p x squared, where P is the distance from F to L. Alright, so they want us to create a proof for this. Alright, they want us to prove this. Alright? So, let's look at this. So we're going to let A be the point on the perpendicular line to L that passes through F. Alright? So we're going to let A be the point on a perpendicular line to L that passes through F, which is the midpoint of the line segment between F and L. Alright? So this is our midpoint between F and L. Alright, so translate A to the origin and make that here. Alright? I want to translate that to the origin using a translation. Alright, but when I translate that, I translate the whole entire thing. So when I translate that, this is what it's going to look like. And I'm just going to redraw this. So when I translate it, now remember a translation is kind of just a slide. So I'm going to slide it down. But I want to slide it down so that A is at my origin. Alright, so here's A prime because I have changed that position. Alright, so since I've done that, here's what I get. Here's F prime. Alright, and I'm going to redraw that line that we put through there. Alright, and then here's my other part. So I'm just going to, and this would be L prime, okay? I'm just going to translate it, all right? All right, now I want to translate, or next I'm going to rotate. All right, so now I want to rotate my figure so that F and L are, so that F is on my y-axis. All right, so I rotate that, and this is what I end up with. And you guys know what a rotation is. I'm going to rotate that at point A. So point A does not change, or A prime, sorry. A prime does not change. All right, but I'm going to rotate that, and now look what happens. There's F prime. It actually becomes F double prime because I've now changed it. All right, and now there's my L. So now it looks like what we've been talking about. There's my focus, my origin, and there is my line of directrix. All right? So my distances never did change though, because when I rotate, translate, or reflect, so this still stays 1/2 P. All right? Since P is determined by F and L, the first translation takes P to the parabola P prime, such that P is congruent to P prime, because I didn't change anything. The rotation takes P prime to a parabola P double prime, so therefore P prime is congruent to P double prime, because once again, I did not change anything. So now I know that P double prime has the same equation, y is equal to 1/2px squared. All right? And that's exactly what we wanted to prove. All right? All right, so let's look at exercises 6 through 9. Restate the results of the theorem in example 2 in your own words. In other words, the only thing you're going to have to say here is all parabolas that have the same distance between the focus point and the directrix are congruent. So all parabolas that have the same distance between the focus and the directrix are congruent. Whole point of this lesson. How do I prove they're congruent? They must have the same distance between the focus point and the directrix. Create the equation for a parabola that is congruent to y is equal to 2x squared. Explain how you determined your answer. Well, the only thing that's going to matter, as long as the coefficient of the x squared is the same, then the parabolas are going to be the same. So I could say y is equal to 2x squared plus 3. It doesn't matter. As long as this coefficient, as long as this is the same as this, then my parabolas are going to be the same. Okay? Because that is my distance between. If you look at it here, the distance between 1/2 p. If you go back over here, and we really didn't do anything with the math there, did we? But you're going to see, as long as your coefficient is the same of your x squared, then you have congruent parabolas. Create an equation for a parabola that is not congruent to y is equal to 2x squared. Look. Why are they not congruent? Because this is not the same as this. The plus or minus, whatever, the plus 1, plus 3, it doesn't matter. What matters is these need to be the same. Write the equation for two different parabolas that are congruent to a parabola with a focus point of 0, 3, and the directrix line y is equal to -3. Alright, so, think about this. I don't even have to go through the whole distance formula and everything. If the focus point is at 0, 3, that means it's 3 from the vertex. And the y is, or the directrix is at -3. That means the focus to the directrix is a distance of 6. Alright? So, the distance from the focus to the directrix is 6 units. Okay? So, any parabola with a coefficient of, let's say, let's put 1/2 p is equal to 1, so p is 6, 2 times 6, so 1/12 will be congruent to this parabola. So I can say y is equal to 1/12 x squared plus 2. Y is equal to 1/12 x squared, period. Those would be congruent parabolas. Alright? They would be congruent. Alright guys, if you have any questions, please reach out to me. I do realize these lessons were a little bit more difficult, but hopefully not extremely difficult. Alright, hope you have a great rest of the week, guys. We are counting down. We're almost there. I'll talk to you next week.